What is the smallest angle that can be resolved by the Carl G. Jansky Very Large Array in New Mexico, which, by the way, was formerly known as the Very Large Array. And the reason, well, you'll have to look it up on Wikipedia. This is like one of the coolest things. I believe it, if you saw Contact with Jodie Foster, okay, I think that was the Very Large Array there. Okay, it's super cool. It's this radio telescope, but it was renamed in 2012. Wow, you just want the answer to this. Okay, has a possible aperture of 42. So that is our B. Our B is 42,000 meters, right? Uses a wavelength of 0.6 centimeters. So the wavelength is 0.006 meters. Is that right? Yeah, that's right. All right. Okay. What is the smallest angle that can be? Okay, we can do this. All right. So when you do this, we're just going to plug into this thing. So it's 1.22, and that's just an empirical factor that basically takes those diffraction patterns and overlaps them. So when you get to single slit diffraction, pay extra careful attention there. And then this is 0.006 divided by 42,000. So this is, it's like a Reynolds number, It actually is. It's very much like the Reynolds number, sort of this arbitrary thing. Okay, so 1.22 times 0.006 divided by 42,000. And I get about 1.74 times 10 to the minus 7th radians. Since this, this wavelength has 1 sig fig, we would say that's about 2 times 10 to the minus 7th radians. Okay. Astronomers do not use radians for the degrees. They actually use a bizarre system of like degrees and arc seconds, right? So what we can do is we can actually turn this thing. Let's take that and turn it into arc seconds. So I'm going to go 1.74 times 10 to the minus 7th radians, right? And if we multiply radians by 360, divide by 2 pi, we'll get degrees. So let's figure out how many degrees that is, okay? So that times 360 divided by 2 divided by pi is 9.985 times 10 to the, I'm sorry, I'm just geeking out here. Okay, that's degrees. Okay. And what you want to do is you want to actually find out how much of an arc second it is. Okay. Now, 1 degree is further divided into hours and seconds, hours, minutes, and seconds, right? Okay. So a degree is actually 3,600. It's like a degree is an hour. Okay, is actually 3,600 arc seconds. Okay, so if I take this and multiply by 3,600, I get that it's about 0.04 arc seconds, which if you go to the Wikipedia page and you look at it, it gives that resolution, and that corresponds to that wavelength. It operates on more than one wavelength. Okay, so I think that's kind of cool. So whenever you look at a telescope like that, they'll tell you its resolution. It's based on the Rayleigh criterion. Okay.